Welcome back to Cloud 42. I'm James. Well, as you know, we've been working on getting a 4-axis DRO installed on the new PM-940 mill back here. We've got the X-axis already installed and working, and the goal today is to get the parts for the Y-axis made, installed, and get the Y-axis running as well. Now, the Y-axis install on this particular mill is probably the most complex of the axes just because of the angles on the base casting, but we have a plan. We just need to make the parts. As a reminder, this is what we're trying to build. The scale itself is attached to the angled side of the mill base with an aluminum rail and a couple of brackets. So we made this rail last time, and it will just be welded with a couple of little stitch or tack welds to these aluminum plates. And then the plates have a slot and a couple of jacking screws. So they can be jacked up off of the irregular casting base to get them to a consistent height so that we can then adjust and get this rail with this front surface vertical and get it consistent so that it moves as the saddle goes back and forth. It tracks smoothly along that. And even if we can just get it close, there is also some adjustability in the end of the scale and some jacking screws in the end of the scale as well. Now the reed head is attached to the end of the saddle with a couple of brackets here. This drop bracket just attaches with a couple of slots. We're not going to bother with the jacking screws, but because I checked and this surface is vertical, at least it's 90 degrees to the dovetails. That drops down. We've got a couple more adjustment slots on this horizontal bracket that the reed head itself screws into. Now there's one thing I've added to the design since last time you saw it, and that is this groove right here. And that groove is to divert oil. Because this is attached to the end of the saddle and the dovetail is right here, some oil is going to get out and get onto this bracket and run down. And if that groove were not there, it would run across this, it would weep in under and around the reed head and possibly get over here onto the scale surface. It wouldn't hurt anything. The scale is IP65 rated, but it would make a mess. So this groove makes it so that any oil that gets down this far will go into that groove and drip off of the bottom of this, probably off of the tips of these screws or off of these screw heads, but it won't be able to go back uphill, get onto the reed head, and find its way onto the scale surface. So that is the plan. Let's go out in the shop and make the parts. Let's start with the rail that mounts the Y-axis scale. And this is just a 1-inch aluminum angle that we trimmed one side off of in a previous video. This is trimmed down to 450 thou. And we just need to put 2 holes in this and drill and tap. And I have my drawing showing where those go. 1 inch, 222 thousandths from this end, and the other hole goes 19 inches, 766 thousandths from that end. Now that's tough to measure. I don't have any calipers or anything that goes that far. I don't want to count that many turns of the hand wheel. But fortunately, we have a DRO on the X, so let's use that. We're going to use a similar setup to when we milled the bridge bar for the X-axis, and I've just got stacks of 1, 2, 3 blocks here to hold this up and support the long ends of it for the drilling forces. And we'll just drop the rail onto there and clamp it in the vise. There's no parallels or anything in the vise. We're just going to use this to hold it in place. Get a little bit of a grip on that. And while this is a little bit flexible, and you can see we can move it, the forces are going to be downward for drilling, so it's not going to be an issue. And there we are on the end of the workpiece. Specifically, we're at minus 0.1 inches because of the thickness of the width of the pin on the end of the edge finder. So I should be able to go down here and say X minus 0.1. Actually, I have to hit 0.1 and then hit the minus, enter. And now we are there at minus 0.1. And so now, if I dial this to 0, then we should be exactly centered on the end of the workpiece, and we are. Okay, let's drill some holes. This first hole is, actually these are both for M4 by 0.7 threads, and we'll just go ahead and drill and power tap them. First one is at 1.222 inches. So we'll just dial over to that position. .222. I'm double checking my diagram. That looks right. And let's put a hole in here. I'll go ahead. Yeah, we'll run it at that speed. That's fine. And while we're here, we might as well power tap it. Of course, I'm going to run it down nice and slow for this. Use A9 lubricant for tapping in aluminum. Okay, next hole is way down at the other end, and it is at 19 inches, 766 thou. And I just ran into a problem. And when I say ran into a problem, specifically, there's a nipple on the back here for the drain for the table, and it is actually striking the bridge bar for the X DRO. That was completely unexpected. I'm just going to remove it and then come back and refine. Oh, it's not even tight. That was an oversight when I put the DRO on. Okay, so I'm gonna come back and refine my X0. And in fact, I think I need to do a quick check and just make sure that I haven't knocked that thing completely out of position. I think we're good. I don't think we damaged anything. But I am still gonna come back and find that zero again. And yeah, it looks like we knocked the zero out by 25 thousandths, and that would have been the slack in the width of the screw slots that are holding that bridge bar on. Looking at it, it looks to me like the alignment's still good. I will probably tear it down at some point and just re-verify all of the alignment on everything, just to make sure that there's nothing wrong with it, but I think we're in good shape. Again, it didn't move the scale, and that would have been the critical thing for alignment. It just was hitting the bridge bar that's holding the reed head, and it looks like it just shifted it over about 25 thou. So I will reset this, X.1 minus enter, and we'll continue where we left off. $19.766. Now I am going to verify this. Using the scale itself, which I have right here. And that looks exactly right. Because there could have been a mistake at any point when I measured the scale. In fact, I didn't actually measure the scale. I took the numbers off of it and looked at the spec sheet for the dimensions of the end caps. So, you know, anything could have happened in there, in the modeling, in making the drawings, in actually measuring here. And the fact that that lines up is nice. And let's put in the hole. think I finally got the spring tension in this quill figured out so I can power tap without making a mess. Use my little Noga rotary countersink to deburr those holes. And that is that part complete. Now the next step is to make the tabs that weld onto this. And the way these work is it's just a tab that's going to be welded like this that will have a slot and 2 threaded holes in it. I will go ahead and drill and tap and slot these off camera. You've seen me cut slots in aluminum before. These parts aren't very interesting, and I will be back when we're ready to weld them. Okay, we're over here at the welding table. I'm welding on a 1/2 inch thick sheet of aluminum plate, just so I have a flat conductive surface to work on. And I've got the tab here, and I just need to set this up centered on the tab and 3/4 of an inch back from the edge. And the way I'm going to do that is I've got some 3/4 inch blocks of aluminum here, and I'm just going to clamp one of these down so it gives me a nice 3/4 inch spacer. Okay, we've got this all positioned and ready to weld, and I could get a good weld on this side, and then I'll probably have to move the clamp to get my weld on the other side. What I'm going to be welding with, this is a Miller Spoolmate 150, and this is a spool gun that feeds aluminum. So my TIG welder is actually a multi-process welder. It does TIG and stick and MIG. And MIG with the spool gun. Now in this case, I'm doing aluminum MIG. So I'm running 035 4043 wire. I'm running at 19.3 volts. And I've done a little bit of testing, and this is about right. In fact, it's the factory default settings for 1/8 inch material welding in aluminum. So this runs with quite a bit of wire speed. It goes really, really fast. The heat builds up really, really fast. And so if you do this, you gotta be quick. I am not an expert welder by any stretch of the imagination. I am a beginner. I have just played around with this having bought the welder. Now I've done a little bit of TIG welding, and it's certainly an acquired skill set. I can do it. I could TIG weld this, but the MIG is gonna be way quicker and way easier. Let me grab some safety gear and let's squirt a little metal on this joint. Well, I wasn't kidding when I said I'm not much of a welder, but that is gonna work. I've got enough penetration there, that's gonna hold. There's quite a bit of splatter. There's been a fair bit of soot with it as well, but I think I'm getting good penetration in there. I did some other test pieces and cut them, and was getting decent penetration from it. So I think that is gonna work. I may flat file and clean up a little bit of the spatter that might be underneath where the scale would have to meet, or where the screw heads will need to slide smoothly. But I think that's gonna work. If you're curious, this is a test piece that I did before I actually turned the cameras on. And I wanted to know, am I actually getting decent penetration? So, you know, these welds look fairly similar. I mean, even that one even looks like it's a little bit up on the surface. But when you cut it and polish the edge, you can see that there is no seam. It's not just sitting on top. I am getting good penetration down in. So I will credit the default settings on the welder for that. Certainly not my skill, but I think we have a part that we can use. Let's get the rest of the parts made. Went ahead and made the drop bracket off camera. This is a very simple part, just a rectangular piece of aluminum, 3/8 of an inch thick, a couple of slots, a couple of tapped holes. The last part we need to make is the reed head bracket here. And this is a little bit interesting because it's got a couple of tapers on it, some slots, it's got a little oil relief groove so the oil will drip off, and a couple of tapped holes. Let's put a part in the vise and make it. This is the blank. I've already got the blank cut to size. I've got a couple of tall parallels in here, and I will just drop this in on those parallels. Now I'm not going to worry about how tight the parallels are because I've got some holes really near the edges, and I'm going to want to shift them over out of the way just to be sure that I don't hit them. I think I will tap this down just a little bit. And that is our oil drip groove. Well, that is the part so far. So I've got the oil drip groove in it. I've got the slots and threaded holes. Now we just need to cut the bevels on the top here. And to do that, I added some features on the drawing to make this a little bit easier. I've got the angle here, 18.78 degrees. We'll call it 18.8. That's just what it happened to be. I was tracing out the dimensions. This end is the same as the width of the drop bracket. And this end is the same as the width of the reed head. That's the only place where that angle came from. I didn't make that up. It just happened to come out to that. But you can see that I have an aligned dimension here of 0.408. And so what that means is that's from the imaginary corner of the part. So if I get the part in there at the right angle, I can touch off on the top, come down 408, and I'll have that in the right position. And again, this is not super important as a feature. I would like it to align right here. That'd be pretty nice. I would like it to align with this part, but again, this part is going to be in somewhere in the slot, so that won't even really be visible. So I'll just take it to this dimension and see how we go. Now, I could do this with a protractor, but what I'm going to need to do is drop this into the mill and then tilt it up at an angle and mill that. And I have one of these digital angle gauges. Now, it would work better if this part were steel. It's not steel, it's aluminum, but I'll just line it up by hand and it should be good enough. So let me get this down to the point where we're almost starting to grip, but I can still move it. And we'll set this to 18.8 degrees. There we go, 18.8. Now we just need to bring the quill down and touch off. And there we're going to touch. I'm going to assume we took about 10 thou with that touch. So instead of coming down 408, I'm just going to come down 400, though I'll do it in a couple of steps. Let's flip it around and do exactly the same thing on the other side. I'm looking at this, facet here, and there's a tiny little flat past the groove here, and there's a tiny little flat past the groove on this side, and they look identical to me. So that means that they're even. Since they look even, they're even. So we'll call that good. And now all we have to do is do a little bit of time traveling back over to the welding table and make sure this gets welded in the past, and then we will go ahead and install this on the mill. I have the reed head bracket assembled, so this is going to go on right here with 2 screws, and I've gone ahead and assembled this with the reed head on it so that I can get this into position, and then I can use this bracket then to position where the scale needs to go. Now, since I only have a couple of hands here, I'm going to use a piece of VHB tape to attach this. At least I'm going to try, see if it'll hold. Well, that's not feeling great. Nope. VHB is not even close to sticking there. Okay, so plan B. I'll put this in place. I will drill and tap one of the holes, and I will use that screw to position it for the second one. Okay. Now, to make this easier, I've taken the power feed off of the end of this, and I've moved the table all the way down so I can get at the end of the saddle here. These screws are going into the saddle, not the table. You can see the dovetail here, the table's on top, the saddle is underneath. So I should be able to just drill and tap straight into this, and there shouldn't be anything that I'm going to hit. I'm just trying to line this up and get it as straight as I can. Going to go a little bit deeper than maybe I would someplace else, just because this is a blind hole and I got to have room for the end of the tap. I apologize if you're hearing some background sound. I've got a water heater right behind me and it's roaring away at the moment. Again, for tapping, I'm starting with a taper tap, and I'm using anchor lube. You can tap cast iron dry, but anchor lube works pretty well. I did have a comment about why I'm not using my tap guide. I actually don't have a tap guide with a size that fits this. If I get the hole that I have in it that fits the M6 thread won't go over the shaft of this, because the shaft of this particular tap is larger than the threads. Now I can print another one, and someday I will, specifically for metric, but it won't solve the problem that the shaft of this tap, the shank, is larger than the threads. Anyway, since I'm starting with a taper tap, it's going to go in pretty easily anyway. And this is my little air blowgun that I showed in the last video, where I have an inflator needle attached to the end of it with electrical tape. I do find it quite interesting that at almost the same time I posted that last video showing me taping the end of this on, Stefan Guteswinter did a really nice video showing how he made a little 3D printed Lua adapter for putting needles on the end of his blowgun. Interesting how those things line up at the same time. Now I'm just going to take a short M6 screw and a washer and attach this temporarily, just so that we can locate and drill the other hole. There's not nearly enough threads on this to hold it securely. I'm just trying to locate the hole. Okay, now let's get some screws that are just a little bit longer and a couple of washers. And let's go ahead and mount this reed head. Okay, there we go. Next up is the scale. Okay, I've got the scale here. This is the rail that we made earlier and welded up, and there are my beautiful welds. And we just need to put this behind the reed head. And again, I've got the reed head in here just so that we have a point of reference for where the scale needs to go. So I'll just slide it behind here. We'll get it behind the reed head, and then I'll slide the reed head in enough that the little flexible wipers will put a little pressure on the scale and hold it in place. And that should give me the opportunity then to try to get it positioned more or less where it needs to go. Now I've got M4 by 0.7 jacking screws in the flanges already, and that'll allow me to level it up here just so that it's not rocking. And then we need to get it in the correct position vertically. So I've got our old friend here, the 123 block with the little Noga mini flex holder on it and a dial test indicator. And I will set that on the dovetail. Now I'm not setting it on the top of the mill because I have no idea how precise that is. I'm actually setting it on the dovetail itself, which is where the which is where the saddle is actually going to ride. And then I will use the fine adjust to run this down and just try to get the height about right. So that's about 0 right there. And over on this end, we're way higher than that. Just bring that approximately up to 0. Okay, those are in about the same position now. Now that is by no means a final leveling because I don't even have any screws in this thing. So I'm just going to very carefully now mark where I want to drill and tap for the screws. And then once we have actual screws in there, we can do some actual final adjustment. Okay, there we go. That one's all the way through. I'm not going to clean these holes out with compressed air, though, I don't think, because they go all the way through, and I don't want to blow cast iron dust into the screw. Okay, so now we're in position. Let's start by trying to make sure that the scale is actually square to the world. And to do that, I need my square. Did you see where I put it? No, it's over there. Okay, so the top needs to come out a little bit. And that is what the jacking screws are for. Yep, that looks good. Okay, next is height. And so we'll just bring back the dial indicator. It's 2 thou under my 0. And that's 1.5 thou under. We're gonna call that good for now. Now what we need to do is make sure that it's on both ends the same distance out. And to do that, I've got a 1/2 inch gauge pin. I'm gonna drop that into the dovetail. I'm gonna push my 1, 2, 3 block back against that. And then I'm gonna readjust to read on the front edge of the scale here. So when I press all the way back, I'm now reading 0 on the front. Put this in over here, do the same thing. And I'm not on it yet. So I need to just pull out with the jacking screws here. And there we are, 1.5 thou. There's my 1/2 thou under. Yep, and I know I'm getting this closer than it needs to be, but why not? There we go. That's within 1/2 thou end to end. And now let's go back to checking the top. Make sure I didn't mess up the height, which is, pretty likely. And 0, okay. That is good. So now we just need to get the reed head in the right position. And it looks to me like we're just a touch high. We can adjust that right here. Okay, that's pretty much centered. And now we just need to adjust in and out. And that is easy to do with our old friend, the plastic shim. That's better. Okay, this is most certainly going to be edited down by the time you see it, but real time, looking at my watch, this took about 30 minutes from putting this in, drilling, tapping the holes, and doing all the fiddling and adjustments. That was about 30 minutes. So I still need to put the scale cover on. And this is the cover that we trimmed down in a previous video, and it will just fit in like that. And we should have a nice, neat little package here. And I will route this cable around like this and up and across and get the scale cover on. And then I think we'll be ready to test it. And there it is, all buttoned up. And I've got the bellows back on there. Now the bellows do just lightly touch the top of that, but I don't think that's going to be an issue at all. There's not any pressure. In fact, it's sort of sagging down and touching it. So yeah, I'll be able to hear it, but I could hear the bellows anyway. So at some point, maybe I'll do something for a better way cover, but that seems to be working fine. And I've got the cable routed up and across so that it's not in the way and it's not sitting down in the coolant or chip tray there. So let's see if it works. So we've of course still got the x-axis, which we've been using all along, and we have a y-axis, and that's actually going in the right direction. Positive is towards the back of the mill, negative is towards me. And if at some point I decide that's not the way I want it, that's easy to change. And by the way, I did go back and readjust the reed head on the x-axis after I hit it with the little drain nipple here on the end of the table. It turns out it was still in position. It wasn't an issue at all. But I went ahead and readjusted it with the shim just to make sure and verify that it's in the center of the scale and that all the angles are zeroed out. So that looks good. So now we have an X and a Y DRO. The last thing we need is a Z DRO, actually Z and quill, but Z would be the next logical step, and it'll be a lot easier to make the parts now that we have an X and a Y DRO, and we actually have a little DRO on the quill as well. And we'll work on that soon. If you enjoyed this video, give me a thumbs up. Feel free to subscribe to the channel and leave me a comment. I'd like to know what you think. Thank you for watching.